Welcome friends in Home Electronics channel. Today we will discuss about the DC power supply circuit. This is our first episode. To run any electronic circuit, we must have the power supply. In general, the DC power supplies are of 12 volt, 5 volt and 24 volt. Making stable power supply is not a very easy task because there are loading effect issues. Due to the loading effect, the output voltage drops after connecting with the load. Hence, I have decided to discuss or explain the different power supply circuit in the very first episode. Broadly, DC power supply are of two types: unregulated and regulated. Unregulated power supply, a power transformer and a just few rectifier and filters are used to convert AC to DC signal. In this power supply, output voltage is not very steady. On the output of the regulated power supply is very stable. The regulated power supply are two types: linearly regulated power supply and switch type regulated power supply, or SMPS. The linear regulated power supply. With unregulated power supply, if we connect the regulated IC like 7812, 7912, 7805, etc., we can get a regulated linear output. Switch type regulated power supply, or SMPS. The switch type regulators or SMPS are consisting of high frequency transformer and current and voltage limiting IC with their bias circuit. We will discuss detail in later episode. Before discussing in detail the linear regulated power supply circuit, let us quickly brush up some basic knowledge. This is the diagram of full bridge rectifier, and this is the diagram of center tap transformer. Depending on the output voltage, we choose the transformer and the other components. In this circuit, the output voltage is 12 volt. As we know, the AC voltage follows sinusoidal pattern. This is the sinusoidal pattern. This is the x-axis. This is y-axis. This is voltage. So during positive cycle, this is positives. First diode D1 will conduct, and after transfer, we will get 13 volt. And after diode D1, we get 12.4 volt. 0.6 volt is the diode conduction voltage drop. If we consider RL as a load resistance, then the current will flow through this direction, RL, and close the current conducting path through D3 and D3, but no, D3, not D4. Although both V anode terminal of D3 and D4 are connected with load RL. But as D4 cathode terminal, D4 cathode terminal is higher potential and D3 cathode terminal is 0 volt, lower potential. Similarly, during the negative cycle of the AC input, diode D2 and D4 will conduct, as I have previously mentioned, the silicon diode conduction voltage is 0.6 volt. Here, two diodes are conducting each cycle of AC input. Here, hence, total output voltage will be 13 volt, 13.0 volt minus 6 voltage minus 0.6 voltage minus 0.6 voltage. That is 11.8 volt. Filter circuit, sorry, as we are not using any filter circuit in this diagram, so across the load we will get pulsating DC. We will get pulsating DC. Filter circuit. Filter circuit nothing but combination of capacitor and inductor. Capacitor and inductor both offer resistance. For capacitor, the resistance is called capacitive reactance, that is Xc, and for inductor, the resistance is called inductive reactance. Xc is equal to 1 by twice by Fc and XL is equal to twice by FL. This is the formula of capacitive reactance and this is the formula of inductive reactance, where F is equal to supply frequency, C is equal to capacitance in Faraday, and L is equal to inductance in Henry. Depending on the power supply output, hence it is clear for DC, capacitor will act as a open circuit and inductor will act as a short circuit. Because the F is equal to, in DC, F is equal to 0. Now this is the our main circuit where I have used center tap transformer and voltage are plus minus, output voltage are plus minus 12 volt, plus 12 volt, minus 12 volt, plus 5 volt, minus 5 volt. In the transformer middle point indicate the common line as 0. As we are targeting to different voltage, that is 12 volt and 5 volt, hence we are using different capacitor value for different output. For plus positive and negative 12 volt, we have used 1000 microfarad capacitor. 1000 microfarad electrolytic capacitor 35 volt, and for plus 5 volt and minus 5 volt we have used 100 microfarad capacity electrolytic capacitor, 100 microfarad electrolytic capacitor 63 volt. Also, we have 4 regulator IC for positive 12 volt plus 12 volt, it is 7812, and for minus 12 volt it is 7912. For plus 5 volt plus 5 volt it is 7805, and minus 5 volt it is 7905. Here, one important thing we should note down that for negative voltages, that is minus 12 volt and minus 5 volt, the positive terminal of the electrolytic capacitor should be connected with the common line. That is the middle point of the center tap transformer. In next episode, we will see the actual running linear regulator power supply using this circuit. Thank you.